Okay, good morning, everyone. Let us start. So first of all, can everybody see the text clearly? Do I need to increase? Okay, great. So we're going to continue working through the syllabus and course policy, regulations, all kinds of stuff today. So please bear with me. It's kind of like a tedious, but I do want to give you a comprehensive overview of this course and emphasize some kind of possible challenges and also the time and efforts you need to commit to help you make a better decision. Okay, so I will come to that point later. So I think at the end of last lecture, we have just started looking at the syllabus. So this is a course webpage. If you just click the link, you will go to this course webpage, or you can just search my name on Google and click the first one, and you can see my homepage here. And if you just take a look at this teaching section, there's an open link to the current course I'm teaching. Always an open link to the course I'm teaching. So you just click into that, you go to the course website. This is really important because all the information are posted here, and also the lecture video links, which we're gonna talk about them later. So let us, so you can see the syllabus link is here. So let us go back to the syllabus. Yeah. So we have gave a description about this course. So basically, after taking this class, we hope that you can understand machine learning ideas and paradigms. I mean, in general, not restricted only one particular approach like deep neural nets. Hope that you can give you can have like a general sense, like for any machine learning algorithm, what kind of ideas, what kind of considerations you need to take into account, right? And you need to be able to, second, we hope that you will be able to identify appropriate machine learning problems for your research applications or whatever tasks you want to address, because some tasks are not suited for machine learning. Sometimes some tasks might be a good fit. So it's not always like, it's not like that machine learning can address all the problem. It's not like that. And one important thing is that you need to know, okay, this might be hopeful if you use machine learning to address that. And for this problem, there's no hope. And third one, we expect that you will be able to design some machine learning models, design meaning that you don't need to create a model, invent a model from scratch. You might base it upon the current, the state of art, or the most popular ones. You make some kind of smart adjustment according to the problem, according to your experience and feedback and so on. And then you will be able to implement these learning algorithms. Of course, it's not necessary to implement from scratch. You can use appropriate tools like PyTorch, TensorFlow, or whatever other machine learning libraries. And also we listed a set of reference books, but here I want to emphasize again, there's no designated textbooks. So all the content is self-contained in the lecture slides. So that's why I highly encourage everyone to listen to the lecture first, then look through the slides. That give you all the details. If you just look into the slides, you might, you might lose yourself quickly. But if you can follow the thread we're discussing during the lecture, you won't miss, and it will be most effective way to learn those stuffs. To my knowledge, okay? But if you're interested, like you have enough time, you want to dive into more content and more depth, you're free to check out those books. I guess, yeah, I think all the 5 books are have the open source PDF online. You don't need to pay any dollar to purchase that. That's why I listed them here. And feel free to read through them, okay? And then this is about prerequisite. Actually, I cannot memorize the course number for the prerequisite, but here I want to emphasize what do these prerequisites mean, right? So basically, in order to feel good about this course, I mean, in order to feel like, oh, you finally learn something rather than being tortured, we do request that you're comfortable about your background in 3 aspects. First, you know some basic concepts in probability theory and statistics, which I do believe everyone has that background. As long as you take some basic statistical course or mathematical statistics course, you should be able, you should have such kind of background. And second, you're familiar with concepts and notations in linear algebra and vector matrix. And of course, I believe everyone has taken the linear algebra on your college, right? If you haven't looked at them for a while, like please start doing homework 0 and find some weekend and open your old textbook and look at some basic definitions like what is determinant, what is the rank, right? How do you do matrix multiplication? How do you do inverse? All those kind of stuffs, right? What is linear space? Those are really, really fundamental in machine learning. I mean, not only in this entry-level course. So even in the future, if you want to do some advanced stuffs in machine learning, the basic language is vectors and matrices. So that people will just describe everything. Okay, I got data which is represented by data matrix, right? I got the parameters. I either represent it as a long vector or a set of matrices which represents the the strands of the edge across each layers in the neural network, or I can represent as high order matrices like tensor structures, right? So you will need to get used to vector matrix languages in describing the problems, in formulating the problems and describing the algorithms. And we'll talk about a little bit about vector matrix derivatives, and you should have some concepts. You're not required to be like a master of taking. You're very good at like manually deriving matrix derivatives and vector derivatives. It's not required in this class, but you do need to have some concept, and also for some very simple derivation about matrix derivatives or gradient, you should be able to do that. If you can start taking a look at our homework 0, I think the last question or the second last question will ask you to do that. That's not hard. You can just follow the reference we provide today, like at the end of this lecture slides. There are some kind of formulas you can follow to do that, but it's a good way to stimulate your memory about doing calculus and also review the idea of the derivatives or concepts of derivatives. Okay. And finally, the third aspect is very, very important. You need to have some basic capability to design algorithms, to implement, to do the programming and debugging. Right? As we emphasized in our last lecture, this course is not a purely theoretical course. Actually, we emphasize a lot on practice, meaning that we're not just introduce you an algorithm table. We're requesting you to implement the particular learning algorithm following that table, and you need to make sure that your implementation works, right? Not just literally right? You need to run them. You need to run them and test on some data sets, either synthetic data set or real data set, and to ensure it is working, given a reasonable performance. So there can be some kind of gap if your basic programming skills and debugging skills are not sufficient. Sometimes you feel, okay, it's so easy for this like decision tree algorithm or ADA boosting, but when you implement, it just doesn't work. Right? The problem may not be in your mental understanding, but in your programming or debugging. Right? There may be some kind of like very small bug you are not aware of, or some like corner details. You need to be patient and to find it out, right? So that's why I keep suggesting students to start doing your homework early. The reason is that you do need some time to debug your code, right? If you start doing everything like 3 hours before the deadline, even you can implement that, you cannot ensure, you won't be able to ensure that your code is executable or generating reasonable results, right? But again, if you're suspicious about any of the three aspects, I mean, in terms of a background, you should really think about whether you want to take this class this semester. I would suggest you, like, there's for example, for a mathematical background, you can take CS 3190, Foundation of Data Science, and taught by my colleague Jeff Phillips, and he gives a very good view and review, and also intro to the useful knowledge in probability, statistic, and linear algebra, so that you will be better prepared for this class. And also, if you don't have sufficient programming skills or debugging skills, you should really be careful, because it will take you too much time for the coding. I've seen some students like complaining, severely complaining me before, although he has some CS background, but still has some problem in programming. Then that's a problem, right? And you might need to practice your programming a little bit more, right? Rather than just starting doing this. Like, for example, the first homework will be implementing decision tree algorithms, right? And it's essentially a recursive algorithm, and you need to partition the data recursively and build a tree recursively. If you are unfamiliar with tree structure and tree traversal algorithm, or you don't have any concept of that, you might be in trouble. Although, honestly, the tree traversal is kind of like quite intuitive. But you feel difficult about that, let me know. Okay. Okay. Any questions so far? Yeah, if you're good at all those prerequisites, maybe you have some of you have asked me for the permission code. You can now understand why I'm trying to ask so many questions, like 5 or 6 questions I forgot to ask your detailed background, because I don't want you to feel bad about this course, right? I want you to feel like, okay, you really learned something. I don't want you to feel like, okay, I'm being tortured throughout the semester but didn't earn anything, right? That's not good, right? That's not what we expect. Okay. Any question regarding the background? So now let us talk about another important topic about getting help. So as we mentioned, I think in the last semester, like I listed my office hours, which is in my office, and also all the 3 TAs, they have their office hours, and you can see that throughout the whole weekdays, like from Monday to Friday, we have the office hours every weekday, right? Especially on Friday, we got 5 hours for help. So please take advantage of those office hours. According to our past experiences, most of the time the students, including me, the TA, including me, are just sitting there. No one comes, right? So I will highly encourage you to take advantage of the instructor and TA office hours, which is posted on the office, the course webpage and the syllabus. We'll work hard to be accessible to students, right? And we do believe those allocation of office hours should be sufficient to everyone. But if you do want to meet outside of office hours, please send us emails, right? And if you don't understand anything, right, and something, right, don't be shy. Come to the office hours and emails and speak up. Just interrupt me, right, and ask me to clarify. I'm happy to clarify anything during the class or in office hours. What I am most worried is that, okay, you just pretend that you understand something you don't understand, right? That's not good. That will harm your progress and make you feel frustrated. So do not be afraid to ask silly questions, right? So I think it's very important to make sure that you understand every basic concepts, right? And then you can progress to a more and more complicated algorithms or ideas. Okay. And of course, I've seen some on Canvas. Some of you have formed some kind of study group. That's excellent. Right? That's very, very excellent. So you're encouraged to use some kind of discussion group or study group to discuss questions outside of class, and about like how to do the project, how to do the homework, and all kind of stuff. That's totally feasible. However, we cannot allow you to post potential answers for homework. Like, for example, you got like 3 friends, you got a study group. Well, you want to discuss offline how you can address homework problem 1, 2, 3. That's fine. That's totally fine. But you cannot post your answering steps on Canvas. The reason of this rule is that, okay, through the offline discussion, we know that, okay, you are doing some kind of face-to-face discussion, you have some interaction and discussions. We do believe the ideas are kind of exchanging. However, if you just post the detailed steps of how to solve the problem according to your thought, then people can just copy and paste, right? There's not any benefit for students who just copy your ideas. So don't post potential answers for homework assignments, and our TAs will just watch them. If we found such kind of things, we're gonna just delete such kind of post. But you can definitely talk about, okay, if someone asks, okay, I don't know what this what this question mean, or what is the outcome does the instructor or the TA want? You can definitely stand out and clarify. Of course, we're going to clarify as well. Or you can ask, okay, can anyone give some kind of like rough idea or strategy which can be helpful to address that problem? Well, you can talk about, okay, I guess that's related to like Jensen's inequality or definition of convexity discussed in the class. That's a total welcome. But you just cannot type a set of inequalities or proof and saying, okay, just to follow those steps, you can address that problem. That's not allowed. Okay, any question or any concerns? Okay. So we're gonna make important announcements throughout the Canvas, right? And please just watch the Canvas. There might be some notices, like sometimes because of temporal schedule of our TAs, they might change the office hours temporarily, or they have to use Zoom link. Oh, by the way, we are very probably be able to give some physical TA office hours next week. We'll update you very soon, but for this week, we still use the Zoom link for the remote TA office hours. So we have posted the links on Canvas. So if you want to seek for help, especially for homework 0, just click the link at that time. Okay. Okay, so what kind of topics are we gonna discuss throughout this semester? So we here list a tentative outline. Tentative meaning that the largest coverage, but not necessary to cover every topic, but just I want to give you some like very brief overview. Like we're gonna spend most of time talking about supervised machine learning, which is the most important machine learning topic. Of course, there are some other topics like unsupervised machine learning or semi-supervised machine learning, but we will see that the key idea is very, very similar to supervised machine learning. So even we don't have time to talk about unsupervised machine learning, you will be very easy to transit to that topic. Okay, so we're gonna start with a very intuitive. By intuitive, I mean the idea of this model, like decision trees, is very similar to the procedure of human being making decisions. This has been proved by some psychologists a long time ago, right? So we'll talk about, okay, how can we, from the data, extract the set of decision rules, and then how can we aggregate the rules in a very succinct but compact very succinct and effective ways. It's called trees. And I will give some like recursive algorithms to tell how can we effectively and efficiently construct such a trees in a hierarchical manner. This will be our first practical machine learning algorithms. And based on this decision tree algorithm, we're going to talk about several very important concepts called overfitting and underfitting. And so probably you have heard these words in other literature before, like when people are talking about machine learning, when some model doesn't work, the first reaction will be, okay, it must be your model overfit data, right? Overfitting your data, something like that. It's kind of like a little bit overused, this word. But here we're going to discuss what's meaning of overfitting, right? So why overfitting is harmful in practice. I can tell you, if your data has no noises, overfitting is good, actually. And when people hate overfitting, it's just because in practice the data is always imperfect. It always contains some noises. That means if you have expressive models, you have powerful models. Those because they're too powerful, those noises in data will kind of mislead the model, your learning model, and leads to bad results. And then we'll talk about the idea of cross-validation to control the complexity of model. Meaning that you don't need to, actually in most of the cases, you should control the expressivity of your model rather than make it as powerful as possible. And then we'll talk about this is called ensemble learning and boosting. So this is a very smart strategy. Like suppose you have like very weak models, like your model is not good, it's not good enough. But if you can smartly combine them, you can still achieve amazing success. So we got like two types of ensembling approaches. One is just boosting, the other is kind of ensemble. We'll talk about random forest, we'll talk about ADA boost, the one often used to recognize faces in your digital cameras. And then we're going to switch to a very simple continuous prediction models. It's called linear regression. If I'm taking a statistical class before, you might have learned that. And here we're going to focus more on how do we develop efficient algorithm to learn a linear regression model, which is called least mean square approach. We're going to talk about what is gradient descent, right? And what is stochastic gradient descent. And we're not going to talk about very advanced optimization algorithm like Gaussian-Newton, LBFGS, and active set, all those kind of algorithms. This is not the task of our class. But however, we want everybody to know the basic algorithm, the basic ideas of optimization, especially based on gradient. Right? How do you conduct gradient descent? Right? And what's the disadvantage of gradient descent when the data is very, very large, and why should we use stochastic gradient descent? Right? Those are very important, and actually most widely used in modern machine learning approach. Then we're going to talk about linear classifier, and we'll start with a very intuitive but very simple online linear classifier. It's called perceptron, developed about 50 years ago, 60 years ago. Then we're going to talk about a very classical and successful linear classifier. It's called support vector machines. You will see how beautiful, why it is so beautiful. Right? It combines. It is motivated completely from the computational learning theory, and you see that the definition of the support vector machine is essentially to minimize the generalization error bound. You will see why it is called support vectors, right? Where do the support vectors this term arise from, right? And then probabilistic learning, which is kind of like probabilistic framework of this linear structure, the classifiers like naive Bayes classifier, logistic regression, and so on. And then we're going to switch to nonlinear classifiers. Like the simplest nonlinear classifiers can be nearest neighbor classifier. It can be explained in 3 sentences. I'm not going to discuss right now. And then we're going to talk about 2 types of very important ideas to fulfill nonlinear classifiers. One is that, okay, I have like a simple linear classifier. I don't want to build up a nonlinear classifiers from scratch. I'm going to just make some adjustment over my linear classifier. And through that kind of adjustment, I can change my linear classifier into a very powerful and very expressive nonlinear classifier. So this adjustment is called kernel tricks. We'll talk about kernel version of perceptron, and we'll talk about how do we use kernel tricks to fulfill the so-called nonlinear SVM. This part might be the most challenging part throughout this semester, because we're going to introduce several common used concepts in optimization. You'll see what is the primal form, what is dual form, what is Lagrange multipliers. When we switch to dual form, how can I do some further simplification to arrive this succinct form to enable nonlinear SVM? So be sure to follow this, because we're gonna spend quite a few lectures about that. Then we'll talk about another way to do the nonlinear classification. It's called deep neural nets. Perhaps this is the most right now is the hottest topic in machine learning. So deep neural nets is trying to build up nonlinear models from scratch. It won't leverage any existing, other simple linear models. And we'll talk about how what's the definition of deep neural nets, right? What's the key component of deep neural nets? You see that no matter how complex the structure of the deep neural network is, essentially is just a composition, recursive or repeated composition of some kind of affine or linear transformation and nonlinear element-wise activation. It's just like that. And surprisingly, if you just keep doing this composition of operations, you can build up some model you want to be arbitrarily expressive, arbitrarily flexible. It can estimate any function, nearly any function. I wouldn't say like all the function, but nearly any function, especially continuous function. So it's very powerful. And then we'll talk about how do we train a deep neural networks. That's actually the key component of that topic. We'll talk about what is backpropagation, right? And everyone will be asked to implement your own backpropagation algorithm, meaning that you will not allow to use some deep learning libraries. You have to implement a backpropagation algorithm from scratch and test it on some real data set and show that it's working. Right? You see that the backpropagation itself essentially is just a smart usage of the chain rule. Because of this recursive or compositional structure, like linear transformation, nonlinear activation performed element-wisely, you see that it gives us a way to very smartly leverage the chain rule. You can catch the intermediate gradient results and then leverage the chain rule to compute the gradient for the neurons layer by layer until you reach the bottom layer. That's the idea of the backpropagation, and we will give some detailed examples and illustration when we talk about that topic. Okay, and then unsupervised learning. If we have enough time, we may talk about unsupervised machine learning, which includes k-means clustering and inference. Maybe some of you have been very familiar with that, and the Gaussian mixture model, which can be viewed as a probabilistic version of k-means clustering. And throughout this semester, especially at the second half after the fall break, we'll have our TMs to give 1 or 2 lectures about the tutorial of some very common used and popular machine learning libraries like TensorFlow, like PyTorch, and recently there is some rising libraries called JAX. It's becoming more and more popular. We might have some chance to introduce JAX with our TM, because in our previous courses we have introduced TensorFlow, and introduced PyTorch, and we have all the videos in the past years. Maybe you can just share a link, and we asked our TMs to introduce this recently rising libraries called JAX to give you more comprehensive information. And also we're going to give some empirical suggestions. How do you deploy a model? How do you debug? How do you get feedback of your of the performance of a model, and so on? Especially there might be a little bit difference from the debugging you have had your experience in your experience before, because usually to debug a machine learning model, it won't give you like okay, you must have this model to give a 95% accuracy, otherwise your model is wrong. It's not like that, because there are always some noises or randomness during the like data collection, data pre-processing, or even the model running. So it won't give you like 100% sure accuracy as kind of like standard to conclude if your algorithm is correct or not. But usually you can give some like reasonable expectation about the performance. Like for example, if you use AdaBoost, it shouldn't be worse than just implementing a decision tree, right? And the typical observation of AdaBoost is that okay, your training error or training can keep decreasing, right? But it won't cause overfitting, right? So so basically in practice, you will need to have some like more flexible principles to check if your algorithm is working properly, rather than sticking to some like rigorous rules. Okay? So we're gonna, I do believe as the semester progresses and as you do more and more practice, programming practice, you will get that point and better and better. Mm-hmm. Oh, that's a good question. So you're asking what's the difference between linear and nonlinear classifier, right? So so linear classifier, as the literally means that okay, it assumes that your class, your label is determined by some linear function of your input features. Like you want to use suppose you want to predict the temperature today, right? You might collect a bunch of features like I know, like maybe the dressing of your friends, like the sun, right? If it is sunny or it's cloudy, all that kind of stuff, right? So you can come out some kind of function which combine those input features and to predict if predict the particular temperature, right? And like 100 degree or just 78, right? So if you just simply assume, okay, this function is a linear function, this is called linear model. However, if you employ a more complicated model, like this function, highly nonlinear function, like it might be some polynomial function or quadratic function, etc. This is not linear model. And of course, you might think linear model is too simple. Why we should use, or why should we talk about such a simplified model? But in many cases, linear models can give you very reasonably good performance. Is quite robust. And once you increase the model complexity, like you can use like 100 layer neural network. Some cases it is performing well, and sometimes it performs very bad. It's not as stable as simpler machine learning models. I will discuss why. We'll give you some like mathematical framework to explain. It's essentially, this is all about like variance and bias trade-off. Any other question? No. Yeah, deep neural network is a very large topic. And again, I mean, the goal of this work, this class, is to give some entry-level introduction to machine learning, meaning that we only cover those very important and fundamental concepts. We don't have time and to give a like comprehensive introduction of every topic. That's not feasible. But for deep learning, you should be able to, you should know what is backpropagation, because no matter you're using RNN or CNN or transformers, all those kind of stuff, you need to rely on backpropagation for efficient optimization or learning. Other question? That's a good question. We'll first give a quick review of the basic concepts like probability, like random variables, even stuff. That's very quick. Then we'll start with decision trees. Yeah. Oh, you mean for the next semester, not for the next class? Okay, for the next semester, if you're interested in my research area, as I mentioned, I'm doing probabilistic learning. You feel free to register my courses of CS 6190. It's called probabilistic learning. You see that the topic seems drastically different from what we are talking in this semester, but it's like more tailored toward the probabilistic learning stuffs. There are a lot of topics. Again, I want to say machine learning is a very, very large topic. And for any of this subtopic, like kernel tricks, we only talk about basic kernel tricks. How do we use kernel trick to generalize linear models to nonlinear models? But the kernel tricks are far more than this. It actually relates to representation learning. It actually is a mathematical branch. Any other question? Okay, so this is a brief overview of the topics we want to discuss this semester. So now I want to look into another very important thing is about grading policy. Right? I hope everyone gets an A in the end, but I cannot just give you A, right? A based on your performance. So what is our grading policy? Right? So basically, your final grade is determined by 3 components. One is homework. You can see that it takes 50%. So it's most important. And then you got course project. It takes 30%. And then you got final exam, which is relatively less important. It only takes 20%. As we discussed in the last lecture, the final exam is just a way to enforce you to, review what you have discussed throughout the semester, not to help you like earn a super high grade, right? If you're doing well throughout the semester, like you're doing good in homeworks and you're doing good in course project, and you will have a very good grade. So for the homework, like 50% of the final grade, it consists of 6 homeworks, as we mentioned. Homework 0 is just a quick review of the basic knowledge. And then the remaining homework will consist of both the analytical problems and the programming assignments. Right? The programming assignments usually require you to implement particular machine learning models and test them in real world or synthetic data sets. We'll provide you the data set, so don't worry about that. So, and each homework assignment may have a different number of points and depending on the work amount. Right? So regarding what kind of programming language you can use, right? In principle, you can use whatever language you want. You feel comfortable, you feel confident, but here we highly encourage you to use Python, MATLAB, R for the programming because they are most convenient. If you really want to use C++, you can use that, but it will take much more time for debugging, right? If you use Python, I think it's most convenient, and also Python basically, I guess, it's kind of like most popular programming languages by machine learning researchers and practitioners. So using that will make you feel a lot more convenient than others. Right? But again, if you insist on using other programming languages, it's up to you. Right? It's okay, but you just need to make sure that your code can be runnable on K machines, because this is the platforms where our TMs or TAs grade your submissions, right? So we'll have to run your code and see the outcomes, and also we'll look at your code structure and see if all the important components are included. The grading is based on this, like both the black box and the white box test. Okay. And also in the programming assignments, feel free to use existing libraries to finish matrix computation and optimization. I think we mentioned that in the last lecture, right? You can use NumPy and SciPy in Python. In MATLAB, of course, internal support is all kinds of matrix operations. And also you can use the off-the-shelf optimization libraries, and you see that for SVM, you need to use constraint optimization algorithms. You don't need to implement from scratch. You can just use the existing their libraries. But you can now use some APIs that. Yeah, okay. You're asking the difference in terms of expectation for undergrad and grad students in Scala. Yeah, this is a hybrid class. That's a very good question. So basically, we're talking about the same thing. And in 99% of cases, you're doing the same set of problems. The only difference is that the bar for undergrad students to get A, B, and C is a little bit lower than grad students. Because you're grad students, you have more experience. To get A, you need a higher bar. That's it. But for the questions, they're shared. Like you can ask them, and you can exchange ideas with your fellow undergrad and grad students. That's a total fun. Other question? Okay. So course project, like it takes 30%, and you should be doing this course project throughout a semester rather than just the last 3 days, right? So everyone needs to participate in one project that uses machine learning techniques to address practical problems, right? And we want you to create a private GitHub repository to maintain and update your project. Includes your code, your document. We see that you need to submit a few reports, and please do not make your GitHub repository public throughout the semester. Just let our TAs to access your repository. Don't make it public. But after the semester, you can do it for sure. Okay, here I want to go through our course project. Yes, it will take a while. Okay, is this font big enough? Okay, so again, this course project details are listed in course website. Right? If you can check out later after the class. Right? So what kind of class projects you should do, right? So we got two types of class projects. Right? So one is called a competitive project. Right? This is just an individual or solo project. We'll open a Kaggle computation task, which probably just collect one particular data set, and I can tell you what is data set for and what is the task. Then you can submit whatever, you can use whatever machine learning models and algorithm. It's not necessary to be implemented by yourself. You can use off-the-shelf algorithm or make some modification on that. You submit your solutions and to the Kaggle system. They're gonna evaluate the accuracy. They're gonna rank your scores, and you'll see some kind of rank board on that. This is called competitive project. The other is called exploratory project. So basically, you can form a group, at most of 2. You can pick up any problem of your interest, use machine learning techniques to address that. Again, and you can use whatever machine learning techniques you want. Like you can use CNN, RN, transformers, and SVMs, and DenseNet, ResNet, whatever you want. Right? It's not necessary to be the topics we discuss in class. You can use off-the-shelf algorithm. You just test your method on your own problems, on your own data set, with some experimental validation, and give a report. This is called exploratory project. So how can we grade your project? Right? We got several milestones. Right? So first, throughout your project, please create a GitHub repository to update and maintain your project, as we just mentioned, right? So the grading will be broken into the following milestones, right? So first of all, I think in the first 2 or 3 weeks, you need to form a project team, right? So if you're doing competitive project, well, you can simply, that means you're doing solo project. So there's no team required. But if you're doing exploratory project, please form a team, right? You can have two, or you can do solo exploratory project as well. Right? And then you need to inform the instructor. Basically, you're going to submit a very simple paper telling us, okay, what kind of project you want to do, right? If it is explore project, what is the team member, right? This is about project team, right? And then later you should submit a project proposal, right? And again, like for a competitive project, the task is well defined. It's in the Kaggle computation task, so you don't need to say the details about the proposal. You just need to register for the Kaggle computation, right? And make a dummy submission and make sure that okay, you have no problem to submit your solutions and to let the Kaggle system evaluate your solutions. Okay. And also, you should submit your Kaggle user details on Canvas so that our TAs can track your identity. And so that, okay, if you have a high rank, or okay, that guy, meaning like Bob, or is you, right? So if you're planning, if you plan to do an exploratory project, you need to submit a one-page document, right? It's very, very succinct one-page document. Answer 3 questions, right? First, who are in the project team, right? It has been notified here. It's fine, right? And what problem you want to address, right? What kind of problem you feel very interested in? You believe that using machine learning can address that, and why you believe it's interesting, right? Why do you want to use machine learning rather than other methods? What's the problem of the other methods? Why do you think using machine learning has a good potential to address that problem? Answer these 3 questions succinctly in one page. Okay, any questions so far? Yeah. That's a good question. You're talking about the topic of the particular topic you want to do, right, for the project. Yeah, I'll come to that point later. But what you mentioned, that looking at some research paper and reproduce the results is totally doable. Yeah. So, and then we're gonna talk about midterm. During the midterm, it's probably right before the fall break or right after the fall break. We'll request you to submit a 3-page document about what you have done for your project. Right? If you're doing a competitive project, you should have made at least 2 non-dummy submissions, meaning that's just not test submissions, right? You need to really try to address that problem. You can use simple, naive approaches, whatever approaches you want. You submit your solutions to Kaggle. They give you some scores. I want to see that. And then in your report, just succinctly concisely describe what you did, right? And any pre-processing of the data you have done, and then outline your plan for the rest of semester. Okay, so basically, during the midterm, after the midterm has just passed, you should have some like non-trivial trials of your tasks, and then you have a clear plan about the next steps. You should tell us all about this. Okay. And there's a bonus here, right? If you, by the deadline of the report, of course, not including late days, right? And if you're ranked as top 10, in the midterm, you will receive 3 bonus points. Right? So try your best to make your score as high as possible. And if you're doing an exploratory project, here is what you should include in your project. So first, what you have done to reach your goal, right? You cannot say, okay, I just collect the data. That's not enough. You should not only include data, but also you have some test, you have some investigation, right? Even you use the simplest approach like linear regression. You can write down, you can write down your results, right? And then similar to the competitive project, you should detail your plan for the rest of the semester, right? And then you should add some reference to the literature. Right? This is important because whatever a technical report you write, you need to give appropriate reference list. This is about the midterm report. Any questions so far? Okay. So final report, right? Final report, it takes most important portion, 65 points, right? If you take a look, all those points as together is 100 points. Then we just multiply, say, 30% to give you a final, to give you points in the final grade. Right? So 65% or 65 points weigh the final report, right? So the length of final report is up to 6 pages, right? Size 11, right? Don't make it too large. Too large meaning that's too short. It's not that's not a lot, right? And this report should be structured as a small research paper, right? Here are the content we expect. First, you should give some kind of formal definition of your problem and also explain the motivation of doing this, right? Like what problems did you choose? Why it is important or interesting? Why do you see? Why do you use machine learning techniques to address that? It's basically kind of retrospective review of the project proposal. Right? Of course, if you're doing competitive project, well, I think it's even easier for you to write down the motivation and why it's interesting, right? Because if it's not interesting, we won't make it as a Kaggle computation. Right? But for your own research, for the Explorer project, you should explain your motivation again, right? And then your solution, right? What kind of techniques, what kind of machine learning models and algorithm you choose or you develop, or if you're doing some theoretical stuff, so you might give you might list the details of proof, derivation, justification, and so on, and then what is your experimental results, right? So you should have a detailed and thorough validation procedure to show that your idea is working or fail. So don't worry that you finally do not get some good results as you expected. That's fine. This is not something we want you. You can always succeed. You cannot fail. It's perfectly fine. You're saying, okay, after all this kind of efforts, I still fail. It seems that machine learning or this type of machine learning techniques do not help address this problem. That's totally fine. This is also a meaningful conclusion. Like failure also is good indication telling us, okay, don't try this again. Right? And then a little bit more, you should add some future plan, right? If you want to, if you continue onto this project in the future, or you have an opportunity, right? What you would like to do, right? In the next step, right? So you have some experience of writing papers. This is basically the structure of paper writing as well. Right? If you're doing purely theoretical project, right? That means you don't need to conduct any. Oh, question? Of course. Actually, you're highly encouraged to do so. So this is kind of like a technical report or more like scientific writing. Using some well-defined template is always encouraged. It's not like your composition some new articles or novels. For scientific papers for technical reports, a well-defined format and template is always encouraged. I won't provide. You can search on the web. There are a lot in the web, and you can do that. You can use your own format. Like first section is introduction, second section is model and algorithm, third one is experiment, fourth one is relative work. It's up to you. As long as it should be clear and easy to go through. That's it. Other question? Mm-hmm. It's not like if you're not listed as top 10, you won't receive any grade. It's not like that. So basically, as long as you try enough submissions, you give some reasonable scores, you will get a full grade. But it might not be sufficient for you to get extra bonus, as we discussed, right? Here, I want to emphasize here, right? So by the deadline of the final report, of course, not including late days, if you're ranked as top 10, I mean, for the Kaggle computation, you receive 7 bonus points. And in the midterm, of course, if you rank as top 10, you receive 3 bonus. Right? And if you're doing a theoretical project, which does not need some like experimental validation on data sets, then we're going to grade the experiment and the solution all together. Right? And again, I want to emphasize again, right? The final project should include a GitHub repository that links to your implementation of project, right? So we're not only reading your report, we'll check your implementation as well. So missing the GitHub link will lead to 0 grade. So don't forget about that. Okay, any question so far about the course project? Mm-hmm. Oh, yeah, talking about the if you're doing a group project, if you have a higher expectation, no, we don't have. But I would emphasize there is no group for competitive projects. You can only do group project on the exploratory project. You can pick up any research problem, any problem you feel interested. You form a group, and most of 2 of you can do something together. Right? But if you're doing Kaggle computation, this is only solo project. Any other questions? Is my clarification? Okay. And also, if you're doing experimental validation, should be rigorous and choose fair baselines and apply cross validation for hyperparameter selection. Report both positive and negative results. Don't hide negative results. That's important. And don't worry about the failures. The failures also are important. Right? And that's pretty much what's the requirements for the course project. And now I want to give some examples about topics for exploratory project. Someone has just asked before, right? So there's no particular restriction about topic. Right? Any project that use machine learning as a critical step or component will be fine. Right? As long as you feel interesting, as long as you will it is valuable, that's totally fine. Right? And however, if you feel like not clear about what kind of ideas I should do, right? So here I give you some examples, right? For example, you can do some application project, right? So you want to apply some machine learning techniques to your problem, like your. I got some past experience. Some student they're in some sports lab, looking at the harm of some sports machines or whatever. They want to use machine learning techniques. To me, it's really, really interesting. Right? So this kind of project is totally doable, right? And also reproduction of the published results, right? So if you're not sure, you don't have any particular problem you want to use machine learning to address, why not just read through some machine learning paper, right? And you want to reproduce the results and see if you can reproduce them, right? So there is some possibility that you cannot reproduce the result. It is possible because there's so many publications in machine learning area. Our group also found several cases where you cannot reproduce the result. That's good, right? That's good, and you can say, okay, I cannot reproduce them. They either do not provide enough details, and I try to implement those details for myself, but I failed, or they have some errors, right? It's possible. You can do some theoretical project. If you're from math department, statistical department, you might be in favor of more theoretical stuffs. Yeah, feel free to pick up some interesting theoretical learning problems like generalization error bound. You want to tighten it with some kind of tricks, with new concentration inequalities, all kind of stuff. That's very welcome. An algorithm project, you want to develop some new algorithm to accelerate the training of neural network or training of SVM, and so on. That's very good. And also your own research, right? No matter of your PhD students, you must have a lot of research projects, right? So you can pick up any of them and use that as your course project. You can definitely use that for your own research, right? That might be beneficial for both this class and also for your own PhD study. Right? So some more detailed examples, right? If you want to look at more specific examples, click link about Kaggle computation task, right? So this is a kind of like, I guess, the world's largest data science machine learning tasks, right? There are a lot of like data and the tasks, and you can just go through them and to get some intuition or inspiration, right? So sometimes you even don't need to exactly follow their task, right? You can just leverage the data and formulate a relatively smaller or more atomic task. It's up to you, right? And biology and medical study, right? So can we select genes relative to some disease, such as breast cancer, Alzheimer's disease? Actually, this is some of projects I have done in my PhD study. Right? Learning to play ball games like checkers, Settlers of Catan, and etc. Right? And stock market prediction, you can do that as well. But past experience is that no one succeeded in this, right? If you succeed, I think you can directly get an offer from those hedge funds, right? But it's worth trying, and it's funny. You can have fun of this. Detecting sarcasm, hate speech, humor, irony, metaphor, etc. in text is also a very interesting topic, and it's a very hot topic in text mining and natural language processing. Classify rounds of a song, book, movie, and painting is very important task in recommendation, and also a lot of like data on the web. You can use commodity recommendation, right? And can we use customers' purchase records to recommend commodities to all new customers? Is also a very important problem, and also a lot of open data you can use. Software security, can we develop algorithms to identify malwares in Android or in iOS, right? Sentimental analysis, can we develop an algorithm, look at and go through this piece of text comment to see it is positive, emotionally positive or emotionally negative, right? This is also very important text mining task. Spam email detection, right? Using say naive-Bayes classifiers or combination of my naive-Bayes classifier and deep learning. There are a lot of such kind of examples, right? Here just list a few for reference. But I guess this would be a good starting point for you to find some topic you are interested in. But one last suggestion about that is that don't try to pick a very hard problem or very big problem. This is just a cost project. Right, so don't try to address like how can we solve the overfitting problem of deep neural nets. That's too hard. It's not necessary. Right, pick up some small enough problem, but not too trivial. Then make some effective investigation on that. That's the goal of our cost project. Okay, regarding course project, any questions so far? What kind? Oh yeah. That's a good. You're asking about due dates of milestone. Yeah. We do have due dates. We'll release the dues soon. At least the first the project choice and project team. They will release very soon. I think it might be due to in the first 3 weeks. You definitely need to get clear what kind of project, what kind of team you want to form. Yeah. We'll release the dues from as we proceed. Yeah. Mhm. That's an interesting question. So basically, I always want to the midterm report to be submitted right before the fall break, because I don't want you to spend any time in doing those things during the fall break. I want to enjoy the fall break. But according to my past experience, it's mostly will be deferred to after the fall break, right? And if everyone agrees that they want to submit right before the fall break, you're welcome, right? But perhaps many of you will ask, okay, can we defer it to after fall break, right? Yeah, we will consider some kind of request for postponing the deadlines. Mm-hmm. It will be graded by the TAs, but as I just mentioned, right? So it won't be based on your performance on that task. Yeah. It will be graded throughout the whole the milestones. Like you submit the project team and project choice in time. You submit the project proposal in time. It contains all the elements, and you submit midterm report in time. You got final report in time and covers all the points we want to discuss. Then you will get full grade. You mean you look at the past Kaggle I think I won't release that because this is private. It's a class Kaggle computation task. It won't be public, so I won't release that. And I don't want you to feel like, okay, this is you want to make a lot of practice to get some high grade. I want you to get some practice about machine learning to address that problem. Yeah. Oh, if you want to look at the difference between them, you can pick up any Kaggle, because yeah, computation, there are like millions of Kaggle computation tasks, and it won't be very complex. Like probably it's just the prediction task. It won't be that hard. But you do need to submit solutions and ranking, scoring, those kind of stuff. Yeah. Mm-hmm. Yeah. Yeah. No, you should have. You should submit a meta report. Yeah, as we mentioned here, right? Yes. Yeah. You need to submit both midterm report and final report, and explain you what you have done, like in midterm project. You're applying for the rest of the semester, all those kind of stuff. Yeah. Any other questions? Okay, so if you have some further questions regarding the project, feel free to post questions on Canvas or ask me during the office hour, or ask TM. So now we're gonna go back to go back to our go back to our syllabus, and here is the letter grade mapping. Right? Someone asked what's the expectation difference for undergrad and grad students. The expectation is only here. Because finally we're gonna letter grade, right? So we're gonna mapping from your numerical grade to letter grade, and here we have several letters, and what kind of range of points you got can give you A minus, B plus, B minus, so on, right? So you see that for undergrad, like 5350 senior undergrad students, the bar for you to get an A minus, B plus is a little bit lower than the one than the one required for the grad students. but that's pretty much the only difference, right? So we'll round up your score to the closest integer values. So for example, if you got some final numerical grade is between 90.5 to 90.9, it'll be treated 91, so that means you get A, right? If it is 90.1 to 90.4, it will be truncated to 90, right? So you will get A minus, right? And if you're stressed about that, and if you're like, okay, I only need 0.1 point to reach A, you want to get A rather than A minus. After that, please come to my office, and we'll try to look at some places where you can increase we can increase your point. But if you cannot find it, you're where you are. Okay. And here's the final exam. This is also posted in the course website. And again, we tentatively will schedule the final exam in this room, but probably will just change it to be online, right, for health or safety. Right? Okay. Another important thing is about late policy. Right? So each assignment must be turned through Canvas by the designated deadline, which is usually some Friday night, 11:59 p.m. Right, to receive the full credit, right? So if you miss the deadline, as long as you miss, you got some 10% penalty due to the late submission. And then every subsequent 24 hours, you will have another 10% late penalty. Right? For example, if you submit an assignment, full credit is 10 points, and if you submit it like 10 hours after the deadline, you'll have 2 points off because of late submission. However, if you submit it like 30 hours late, because it's past 24 hours, you got another 10% credit off, because every subsequent 24 hours late, 24 hours will have 10% credit. So basically, if you submit 30 hours late, you'll have 1 point off because of late submission, another point off because 24 hours late submission. Right? However, we only have like 48 hours late submission in total, right? Meaning that if you submission is like 50 hours late or 70 hours late, then we cannot give you grade and just give you 0 point. Right? So be sure to submit in time. That's why I keep requesting everyone to start doing homework early, and don't rush at the last minute. You will unnecessarily lose some credits. And assignments will be posted far enough ahead of time, and usually if you don't have like if you just got a code, you say I want to personally to have some late submissions, it's not very reasonable unless you have like a very emergent health issue or have some emergency in house, like you have to call 911 to deal with a lot of stuffs. I will consider the additional extension for your own homework submission. And for the prolonged illness or those emergency stuffs, please provide some document. This is just to be fair to all the other students. Mm-hmm. Oh, it's just the typical paper exam. There are most of the cases will be like single choices, multiple choices, and some kind of handwritten. If you're doing online Canvas exam, I think 99% will be just choices or multiple choices. Yeah, both will have. Yeah, but we'll tell this is just single choice, and this piece of problems, you might have multiple choices. Yeah. Mm-hmm. Yeah. That's a good question. So this is open book. You can bring cheat sheet. You can print out the slides. You can bring whatever book you want. You feel helpful for the exam. However, you cannot bring electrical devices like cell phones, like iPads, like laptops. That's not allowed. It's just a yeah, just to avoid that someone post the answers on Stack Overflow or Reddit, and to have some other ones sharing. I mean, any access to the internet is not allowed. Yes, yes, the same task. Yeah, otherwise, how can we compare your scores? Yeah. What? How many tasks provided for compare? Just one task. Yeah, just one task. You just use your whole semester trying to improve your performance in one task. Other question? It's not over Zoom. It's on Canvas. Yeah, it's on Canvas. And I think given that amount of time, you might don't have time to check answers online. No, I won't ask you to fill out. Okay, I leave you one blank line. You fill out like C++, one line of C++ code. That's not like that. Yeah. I assume that okay, your programming or practice has been done in the programming assignments and then in the final exam. Yeah, some knowledge, your understanding of basic concepts. You're not confused by something. Yeah, like that. Other question? Okay, so yeah, if you do want to ask for some personal list submissions, permission for list submissions, Yuri will request you to submit some documents, like either doctor's notes, or if it's 911 emergency, I might ask for some like witness letters and some like. I document this is simply for the fairness. I want to be fair to all the students, right? So please bear with me about that requirement. And if you believe there's some error in your homework grading, that might happen in some cases, right? So please request regrading within 1 week of receiving your grade, okay? Because our TMs or TAs are they're working hard as well. They have their own schedule as well. So if you find anything wrong, if you're not sure about why they give you a smaller, less points than you expect, you can reach out to them and ask, or even ask for the regrading. Okay, so you should send me an email explaining why you think the solution is correct and why you think this kind of grading is not fair to you, and then I will forward your request and also your UID to the TA, and he's gonna regrade that, and he's gonna provide the reason if he insists that his grading is correct. Okay. Yeah, homework submission, right? We only accept homeworks written with LaTeX. Right? Please bear with me. So because everyone in nowadays, like if you are doing any technical stuff, so everyone should know scientific writing with LaTeX. And good thing is that this is really easy, given that we need to deal with quite a lot of mathematical formulas. If you're using Word or something else, is really painful. So I highly encourage you to start doing LaTeX now. And there are some kind of template and document about talking about how to use LaTeX. And every time when we release the homework, we'll give the LaTeX source of that homework. You can just add it on top of that. It is very, very convenient. And also we suggest you use some online LaTeX editor. It's called Overleaf. It's very, very popular. It's free. And you can just copy and paste those LaTeX source provided by us on that, and you just write down whatever your answer is there and compile that. You'll see that immediately on the right hand side of the screen on the browser. It's very, very convenient. Okay. And attending final exam, well, I think it still spend like 5 or 10 minutes finish all this. Okay, let's stop here today. I'm sorry, I might take a bit lengthy time to discuss all those requirements, but again, I do want you to learn or know the comprehensive information of this course to help you make decision and help you feel comfortable about this class. Okay, see you on next Tuesday.